for that intro, Ryan. Hello, everyone. I'm Ursula. I'm with the tech team at Democracy Works. Okay, so lying at the heart of the Civic Data Information API is the concept of political geography, which is a standardized semi-hierarchy of national, state, and local jurisdictions combined with geographic boundaries over time. And so what the API facilitates is a method for linking individual street addresses and thus the people who reside at those addresses to data about their political representation and their election administration, such as polling place locations. And so this concept is embodied in a common set of unique and predictable open data, open civic data identifiers, known as OCDIDs, which in essence is a useful way to organize data across political geographies. And I'd like to make a quick note that when I speak of political geography, I'm not limiting my scope to elected officials alone. I am also talking about any government service with a geographic component, such as water districts or sanitation districts or police precincts. And, because not every street address in the United States incorporates the same combination of political geographies. For example, in New York State, unlike Delaware, there's no court of chancery, for example. The OCDID standard of unique key value pairs allows for omission of data as much as it does inclusion. And so those in the open government community who conceived of the open civic data identifiers identified a fundamental problem of the lack of interoperability in the open gov space, in that the ability to connect data among disparate data sources while referring to the same political geography, that ability was simply did not exist before the open civic data identifiers came into existence. And so it wasn't for a lack of geographic taxonomy, but we certainly didn't see an identifier standard that permitted human readability as much as machine readability. So when you think of FIPS codes, for example, the same identifier that we see in this last comma-separated value in this OCDID here, which is incidentally the OCDID for my current home address, this country, US key value, and county kings value are represented in FIPS as the numeric combination of a state FIPS code and a county FIPS code of 36047. And so while that is sublimely machine readable, it's certainly not very, humanly readable, not easy to determine unless you have a fairly thorough knowledge of the various FIPS codes. And so the community behind the OCDID concept was, painfully aware of this lack of interoperability and designed OCDIDs with that interoperability in mind. And, so this, of course, accounts for jurisdictions, political geographies where we don't necessarily have a readily identifiable geographic information system data set, such as a shapefile. Another concept attendant, to open civic data identifiers is that we are talking about reliable identification of these political geographies associated with an individual address. These, of course, indicate where and for which offices a voter at that address is able to cast a ballot, as well as who represents them in elected office or in the civil service. But there's also a temporal element to political geography as much as a spatial one. And because civic data identifiers are references to geographic boundaries rather than the boundaries themselves, and we'll get to that in a minute, and that they're references to offices rather than the office holders themselves, data in the form of OCDIDs always points to the current and correct versions of politically geographic districts. And, because we all know that combining each data set with others enhances the effectiveness of any given data set, let's engage in a quick data mashup using the Google Civic Information API and a data set from the New York City Open Data Catalog. In this example, we will be using the Open Data Catalog data set referring to the location of Barnes Dance intersections in New York City. What is a Barnes Dance? This is a very well known implementation of the Barnes Dance in the city of Tokyo, wherein we have a complete traffic stop in order to facilitate pedestrian crossings in an intersection. And please note the code that we include in the presentation here is going to be available in the GitHub repos that are listed in the RSVP page and also listed at the end of this presentation. So and we're implementing this mashup in R using the R Socrata package to read in the New York City Open Data dataset. And we are making a simple GET call to the Civic Info API using the header package in R. And I've highlighted here the endpoints for those two data sets. And so writing a simple function wherein we make the request and we spit out the output and manipulate it into a data frame, or in this case, a tibble, because we're operating in the tidyverse. What we are allowed to do is use regex in order to isolate the numeric value of in this case, the state legislative district lower key value pair, which is the New York State Assembly District. That is a variable available in the Barnes Dance data set that we will use to isolate those state assembly districts that are associated with the total of 3 addresses I have occupied while living in New York City. And so this is the output of that call set. And the state legislative district lower key value that we've used to match to the assembly district variable that's in the Barnes Dance data set, including the main street of the Barnes Dance and the cross street, so on and so forth, and the installation date. So that's a very simple example of a data mashup. Now, I spoke earlier about the temporal nature of political geography, and I wanted to take a quick moment to illustrate why referencing those geographies rather than embodying those geographies in the open data standard is important. Over the last 4 years or so, what we see here are shapefiles from the NYC Open Data Catalog that reference the state assembly districts that we included in the mashup. And if we move forward each year, we see pretty small incremental changes to the boundaries of those state assembly districts, but it gets, to be pretty apparent as we've crossed a decennial census redistricting. And so you can see some fairly noticeable changes. In a nutshell, the spatiotemporal aspect of political geographies necessitates the reference to those geographies. And lastly, in addition to the representation that one has associated with a given address, I had referenced election administration as well. And we have here, as part of the Voting Information Project, the current planned calendar for coverage of elections and their inclusion in the API. Because this data is curated directly from election officials, it's highly dependent on their schedules. But for those interested, this data is available from votinginformationproject.org. And I will leave everyone with some relevant links. And for the workshop, if you're interested, fork the repo at this GitHub address. And that is also a link to that repo is also available in the one that is referenced in the RSVP page. And I will leave everyone will be using in their
I think we are slightly losing Ursula's internet, or maybe that's just me. But if it's not just me, as her coworker, I think I can fill in. So I believe first of all, hi, I'm Danny. Danny Peace. I'm an engineering manager here at DW. I work with Ursula and with Lauren Langenstein at DW. So what Ursula, I believe, was about to say, I sure hope she was about to hand over the mic to me. If not, I'm sorry for interrupting you, is that the credentials she flashed there on her screen are some API keys that, don't worry, they're not proprietary. They're sort of rate limited and throttled, but they're some credentials that we'll be using to power the project that I'm about to show you. So what am I about to show you? So just to rip off of what Ursula was talking about, the Civic Information API that Google maintains has a bunch of different uses. And again, there's links to all of this in the repo, but what I want to do is kind of dive into what the JSON response looks like, and how this data can be used to power like a very bare bones voter portal demo. So without further ado, one of the endpoints that the Civic Info API implements is this representatives endpoint that takes an address and spits back a bunch of JSON talking about, that tells you what you have in ways of, in the way of representatives who are tied to that address. So we can use this endpoint to basically any web app or whatever could prompt a user for an address and then call this API and then render the response, which, believe it or not, is exactly what we're going to be doing. But in addition to calling the Civic Info API, I work at DW, so I want to show off our API. This API is our elections API, and we have a sort of similar but not identical endpoint, which serves data on authorities. So for us, what that looks like is an election authority, which is sort of different from like a governance. It's more specific to how elections function. So for both of these endpoints, we're going to make a request. We're going to pluck some fields out of the response. We're going to smush them together, and we're going to render them onto the page. Without any further ado, here's a quick little intro to the repo. So this is just the README. There's instructions for spinning this up in Docker or via Node. This is written in JavaScript. It uses Express as its web server and handlebars to render the content, and HTMX for a throwback to the web of the early 2010s, if anybody else misses server-side rendering. So I'm going to go ahead and start the app. And you'll see over here on the right, I've already pulled it up. Don't worry, I have no intention of quitting my job to become a graphic designer. This is just like the best I could do over the weekend. So let's go ahead and give it an address. I have memorized the address of our Brooklyn office. So let's go ahead and put that in. And then when I hit this button, I'm going to be presented with just a big old blob of stuff. Again, not exactly a graphic designer, but you can see here, these are the authorities coming back from DW that tell me, okay, cool, here's my local election authority, here's my state election authority. And then from the Civic Info API, we have our elected officials, starting from the least specific to the most specific. So just very quickly to talk about the code, I think this is we can kind of ignore everything that's going on here and just talk about the API call. So we're making our request, and you'll notice that both of these APIs take address as a parameter. And we just smush the responses together, pass them to the client gets to render it. Everybody's happy. So yeah, just wanted to demonstrate how you could use these things in a way that is actually user-friendly. OCD IDs are, of course, human readable, but only for those who are pretty in the weeds. So this is all, of course, powered by OCD IDs under the hood, but they are not useful for voters because they are just kind of big strings of nonsense. So that, I believe, concludes our little demonstration. The repo, I believe, is public. We've got some credentials there in the chat. If anybody wants to spin this up themselves and take a stab at it, feel free to let us know. We will be here to answer questions.
Hello, I've got one because so Ursula, during the OCD-ID section, you were talking about how there's not any shape files or geographic information included in that. And then Danny did this app where it went straight from an address to all the information about the different authorities that address is subject to. Is there any sort of geographic analysis, or not analysis, geographic match or shapefile work happening in between that's like above the OCD ID, between the little interface you just drew up and that? Or is there something else going on that gets you from like an address to an OCD ID?
Yeah, I love that question. So I think something that might be helpful here is I'm just going to post a link to the Open Civic Data docs. That here you go. So this is kind of like I'll summarize this, but the general gist is this is sort of like how OCD IDs are minted or created. They're sort of like a process for adding to that data set. That doesn't answer your actual question. The answer to your actual question is it is rare that shapefiles are used to generate OCD IDs. And the reason for that is pretty straightforward. It's that shapefiles are relatively new. So a lot of public infrastructure, as I'm sure most of the people in this room will know, is sort of derived from underfunded, understaffed, frankly, undervalued employees who generate these data sets. And they're not always using, oh, sometimes they are, state-of-the-art tools for these purposes. The main source for OCD ID to address mappings is exactly that, just straight up address to OCD IDs. This gets a little bit complicated depending on what kind of identifier there is. So there's a lot of different ones. There's from school boards to statewide to place, which is sort of a generic catch-all. But yeah, their shapefiles is not an integral part of that data set in the way that I'm sure we would all like it to be.
Okay, so then what is the process that takes you from you put in 20 J Street and the app returns, or the API rather returns, these are the authorities that apply to you if it's not geolocating that address and seeing its inclusion? Is there like a giant lookup table with every address in it? Is that basically what's going on?
Pretty much.
Okay.
Great question. Thank you. Oh, and sorry, Lauren and Ursula, if you want to tag anything onto that, consider yourselves more than welcome. This is my hobby horse, so I jumped all over it.
No, completely concur. Just to say that each API call, there is a normalization that goes on under the hood with each address. And so there's no strict requirement for address formatting in terms of abbreviations or commas or the like.